In this problem, we have a frame that's made up by three members, AB, AC, and DE. And the members are pinned together at point A, D, and E respectively. And the frame is supported by a pin support at point B and a roller support at point C. And we need to determine the forces at point D actually. So as we can see, the frame is subjected to pin at point B, which has two support reactions, Bx and By. And roller support at point C, one support reaction, Cy. Excuse me for not drawing a separate free body diagram because I'm trying to save time. So because of that, we have, if we treat the entire frame as one rigid body and draw one free body diagram, we can write three equations. That's enough for us to solve for all three of these unknowns. So resultant force about the point C equals to, out of the three unknown forces, only By has moment about point C. And then the 400 Newton force has a moment arm of 0.3 meter, which is actually this distance right here, which is 0.3. And then the 300 Newton force, which acts on member AC, that has clockwise rotational effect. So from here we can solve for By to be negative 200 Newton. And from the resultant force along the x direction equation, we will have Bx plus 300 equals to 0. Therefore, Bx equals to negative 300 Newton. So we actually do not need to solve for Cy in this problem. As you can see, we solved for both By and Bx by treating the entire frame as one system and from drawing the free body diagram of this entire frame. Now, moving on to draw the free body diagram of member DE only, because we need to solve for the forces at point D. We cannot do that without drawing out the free body diagram of the member separately. It's subjected to a 400 Newton force right here. And then at point D and point E, both of them are pins. Therefore, we will have two reactions for each, dx and dy, and then ex and ey. Don't forget, we're focusing on point D. Therefore, from this free body diagram, if we summarize the resultant moment about point E, which equals to negative dy times 0.6 meter plus 400 times 0.3 meter. So from there, we can solve for dy to be 200 Newton. And that's one of the two support reactions at point D that we need to solve for. And now if we draw the free body diagram of member ADB, at point B, we already know the forces. By equals to negative 200 Newton, so vertical down. Bx equals to negative 300 Newton, so to the left. We have Ax and Ay here. And then we have dx here. You have to change the direction of dx because, again, these two forces, they have to be equal and opposite. And then dy is negative 200 Newton. If I draw dy as an unknown here, I would have to draw it in this direction because, again, this dy and this dy, they are equal and opposite. So because I know what it is, that is 200 Newton here. So now, remember, we are still focusing on only dx. So if we summarize the moment about point A, AX and AY do not have moments about point A. So we have negative 300 Newton times 1.2. And then the first 200, this one right here, plus 200 times 1.2, plus this 200 times 0.6, and then minus dx times 0.6 equals to 0. So from there, dx can be solved to be 0. Therefore, the resultant force at point D equals to square root of dx squared plus dy squared, and that is simply 200 Newton.